The Korean government developed the Sudok-1 landfill to meet increasing energy demands in the country and lower the use of fossil fuels by creating energy from waste. The Sudok-1 landfill is a state-of-the-art regional landfill that brings the concept of resource circulation to life. It is the world's largest sanitary landfill with a total area of 17.18 million square meters and separated into 4 landfill sites serving a population of around 26 million from Seoul City, Gyeonggi, and Incheon provinces. The first and the second landfill sites are filled to its capacity. The third site is under use and will be terminated once it reaches its design capacity of 40 meters high. The Sudok-1 landfill was established in 1991 on reclaimed land in the Incheon province. Acquisition of the land cost 45 billion Korean won, or about $39 million, of which 71% was paid for by Seoul City and 29% paid for by Korea's Ministry of Environment. The first landfill's initial installation cost was 32 billion Korean won, about $28 million, paid for by Seoul City, covering 75% of the cost, and Incheon and Gyeonggi provinces each covering approximately 12.5%. In 2000, the Sudok-1 Site Management Corporation was inaugurated as a public entity under Korea's Ministry of Environment. Since then, the landfill's facilities have evolved to include several waste-to-energy facilities, including a leachate treatment technology facility, sludge recycling facility, food waste effluent to biogas facility, solid refuse fuel SRF plant, and electricity generation facilities including 1.9 megawatt, 2.4 megawatt, and 50 megawatt power plants. Different revenue streams are part of the business model of the Sudok-1 landfill that not only helps to meet landfill operational and administrative costs, but also allows for investment in new projects. Garbage trucks bring non-recyclable waste to the landfill. About 900 vehicles and 14,000 tons of garbage enter the metropolitan area each day. Green garbage trucks transport household non-recyclable wastes and industrial waste to the landfill, and red garbage trucks bring construction waste to the landfill. Waste trucks are painted in bright colors and with festive designs to create a positive image or perception of the landfill. The garbage trucks are fitted with RFID readers that enable SLC to track the movement of the trucks. Using the RFID readers, SLC can determine the areas where trucks have collected waste. This enables SLC to understand the volume and types of waste collected from different areas. The RFID readers, Wi-Fi, and CCTV connected in an integrated system allow SLC to monitor the trucks while they are in the landfill. Entry control and signaling system help SLC to manage the movement of trucks and traffic on the landfill. It also records information about each truck, like weight and violations, if any. Upon entering the landfill, vehicles must first pass through the integrated weighing bridge. The integrated weighing bridge is a platform that measures the weight of waste and the truck. Determining the weight of the waste is needed for calculating the tipping fee. Trucks then move to the inspection facility, where household and industrial wastes, except designated waste, are sampled to determine that there are no violations with respect to the types of waste that are being discarded. If there are no violations with the waste, then the garbage truck moves into the landfill for the unloading of waste. If there are found to be violations, then penalty points are issued or the truck leaves the landfill and returns to the cities or municipalities. Penalty points are imposed on the cities and municipalities for waste violations. SLC has established an IT-based integrated incoming waste management system that includes a violations management system and tracks waste violations in real time and reports these to the municipalities so that they can be further investigated. Unloading of waste. Waste is unloaded at the designated landfills, where there is a second inspection of waste for any violations. High and low resolution CCTV installed in the landfill helps capture images of violations that are fed into the integrated waste management system. Remember that each truck has RFID, so it is easy to detect where waste violations are originating. That is where the waste was collected. Trucks are then washed so that they are free of waste and therefore will not have an odor. This is part of ensuring a positive image of waste management. On exiting the landfill, the empty trucks are weighed to determine the weight of the waste. The weight of the waste is transmitted in real time via the integrated incoming waste management system to relevant municipal offices for the calculation of tipping fees. Municipalities are able to view information on the waste sent to SLC via a waste web portal. Tipping fees vary according to category and volume of waste. As of 2019, municipal solid waste costs $54 per ton, construction and demolition waste costs $87 per ton, and industrial waste vary from $29 to $100 per ton. The Integrated Incoming Waste Management System, IWMS, is a cutting-edge system that brings together several advanced IT and different infrastructure. The IWMS comprises an information system, an operating system, and a control system. These are supported by an e-government framework, wireless infrastructure, and cutting-edge technology like Differential Global Positioning System, DGPS, megapixel cameras, and smart devices. Incoming waste is dumped in the third landfill site at SLC, as the first and second landfills are now full and closed. This landfill separates domestic and construction waste, as these two types of waste need to be managed differently. SLC uses bulldozers to spread out the recently dumped waste in the landfill. Unloaded waste is compacted to 4.5 meters thick, and 0.5 meter interim soil cover is placed on top of it. After completing waste burial each day, disinfectant and deodorant are sprayed on the compacted waste and soil, and 0.2 meters of soil is placed over the waste to avoid contamination. The landfill takes waste from 6 a.m. to 4 p.m. every day and completes waste covering with soil within 5 hours, so that it minimizes the time waste is exposed to the air. In order to minimize the working area, work is performed in and only 3 blocks at a time to minimize the impact on the surrounding areas. The height of the landfill is limited to 40 meters in consideration of the fact that the shape of the landfill site becomes narrower towards the top. Disposal area will be reduced if the garbage is piled up too high, and taking into consideration that the site is made up of a tidal flat layer due to reclamation. As waste decomposes in the landfill, gas mainly composed of methane is produced, which when released to the atmosphere contributes to global warming, and so this gas is being captured for energy production. A bioreactor process is used for the second landfill to speed up the decomposition of waste. Pipes are installed in the landfill to collect gas, and this gas is transferred to a 50 megawatt power generating facility in another part of the landfill. See Module 5 for more information on methane to energy production. The decomposing waste produces a liquid called leachate, and this needs to be treated before it is discarded. The base of the landfill has an impermeable layer that prevents leachate from seeping downward and into the water table or nearby waterways. Pipes collect the leachate and transfer it from the landfill to be treated at a leachate treatment facility that is on the SLC landfill. The leachate treatment facility processes about 4,300 tons of leachate per day. In the leachate treatment facility, leachate is purified, then injected into the now closed second landfill site, and used for maintenance activities like cleaning and water for the greenhouse around the landfill. This is a practice of SLC to have a non-discharge system using cutting-edge technologies. This method can increase the generation of landfill gas by moistening dried waste buried in the landfill site and promoting decomposition. Remember that landfill gas is used for energy production, and so more gas is a benefit of SLC. Leachate is also used to generate methane gas that supplies the 2.4 megawatt power generation facility. In order for the landfill to not become saturated, rainwater is channeled into pipes on the landfill that move the water out of the landfill and into streams. Monitoring of the landfill is done to ensure its optimal performance and operation and safety of the landfill. There are 4 types of monitoring that are done: for management of ground settlement and compression of waste layers, monitoring the slopes, and managing leachate levels. For the management of ground settlement monitoring, SLC uses settlement plates, pore pressure gauges, and water and earth pressure gauges to analyze the weight of waste, compaction, and settlement of the waste layers. SLC also measures the change in density caused by compression of each layer's settlement and uses these analyses to make adjustments, such as adding more soil or cover materials to make the landfill level or horizontal. The slopes of the landfill are monitored closely for stability and to prevent the collapse of the slopes using clinometers. Slope stability is affected by the settlement and compaction of waste in the landfill and the water and leachate levels in the landfill. The level of leachate in the landfill affects its stability, and excessive rainfall may result in a significant increase in the amount of leachate in the landfill. Levels of leachate are monitored via leachate wells, and the outflow of leachate at the pumping station is adjusted to manage the level of leachate. Citizen engagement has always been a hallmark of SLC's operations. Landfills are usually a serious concern for the public, especially for those who live near to the landfill, as they can be smelly, create harmful gases, create problems with underground and surface water sources, encourage harmful pests and insects, can look unpleasant, and the movement of trucks in and out of the landfill can create traffic. This was the case in Seoul, South Korea in the 1980s, where the Nanjido landfill, a 40-meter-high mountain of rubbish, was an eyesore and also a major health issue due to the frequent landfill fires, leachate seeping into the water table under Seoul and into the Han River, and exposure of waste pickers that interacted with the unsanitary waste. Citizens often adopt a not-in-my-backyard, NIMBY perspective of landfills, where they appreciate the value of the landfill, but they do not want the landfill to be situated close to them. So getting citizens on board with the landfill, by assuring them that all of these issues are considered and dealt with, is an important part of citizen engagement. Citizens around the Sudok-1 landfill area, within a radius of about 2 kilometers, were involved from the initial stages of development of the Sudok-1 landfill via hundreds of public hearings. Through regular and irregular interactions with the public, the local governments of Incheon and Gyeonggi provinces and Seoul City were able to listen to citizens' concerns about the landfill, especially the ones from neighboring residents, and provided assurances about the measures that were being undertaken to ensure that the health and safety concerns of the residents could be addressed, as well as the aesthetic and odor concerns. The citizen engagement was not without its share of challenges, as the residents around the landfill organized a countermeasure committee to mobilize collective action to oppose the landfill, especially when it announced a plan for industrial waste intake. In response to this, SLC enacted the Promotion of Waste Transfer Facility Installation and its Local Community Support Law in 1995. Some of the measures agreed with the citizens included the organization of working groups comprising citizens, local government, and SLC to discuss waste intake and waste inspections, to recommend monitoring members among residents, and to empower residents to participate in operating landfills. Currently, there is a strong partnership between the SLC and the Resident Council, which is the representative group for citizens around the landfill, and active involvement of citizens in the SLC's operations. It is essential to highlight that there are dedicated resources as part of SLC's annual budget for citizen engagement. 10% of tipping fees, about $10 million per year, collected by the Sudok-1 landfill are dedicated to the surrounding 38,000 residents and support. Regular medical checkups, scholarships for students, sports park, football, baseball, basketball, volleyball, tennis, running track, community centers, multi-purpose senior centers, a discount on admission fees to SLC's golf and horse riding courses and swimming pool. SLC creates places where citizens can share the value of the landfill by utilizing land there for recreation and educational purposes. The Dream Park was built on the SLC landfill as a green space complete with recreational facilities that can be enjoyed by anyone. These include a sports park, green bio complex, eco-event complex, eco-culture complex, and nature observation complex. A public golf course was established in 2000 on the first landfill site after it was closed and stabilized. The 36-hole golf course, along with other facilities, was used for the 2014 Asian Games, and more than 160,000 citizens visit the venue each year as of 2019. The swimming pool that was built for the 2014 Asian Games has 10 50-meter lanes and is used by many citizens. The Equestrian Course operates rehabilitation horseback riding for the disabled and is developing various programs. A green forestation project is being implemented to make the Sudokwan landfill greener and to promote carbon dioxide uptake. Trees for the project are grown in a greenhouse on the landfill and flowers as well. In the wildflower garden, one can observe wildflowers that change from season to season. Every year, chrysanthemums or cosmos are planted and opened for a certain period for citizens to enjoy the flowers.
The Sudokwon Landfill Corporation, or SLC, developed an energy town to meet increasing energy demands in the country and lower the use of fossil fuels by creating energy from waste. Transforming waste into energy is consistent with South Korea's resource circulation and green growth development strategies. The SLC has developed state-of-the-art facilities for converting different types of waste into energy. The ability of SLC to convert waste to energy in a cost-efficient way is due to their existing system of waste separation. See Module 2 to learn about how waste is separated. Currently, SLC is converting 25% of incoming waste into resources, and it aims to raise the resource conversion rate to 77% by 2023. The following facilities are main waste-to-energy facilities in SLC's Energy Town: a 2.4 megawatt biogas power plant, a sludge recycling facility, a food waste effluent to biogas facility, and a combustible waste-to-energy facility. In order to generate biogas, which is the raw material for the 2.4 megawatt biogas facility, the food wastewater generated from the treatment of food waste is carried in through the entrance of food wastewater. An average of 40 trucks a day carry food wastewater from 6 a.m. to 3 p.m. every weekday except holidays. The imported food wastewater is stored in the biogas storage tank and then transferred to the 4 biogas digesters. The wastewater inputted to the 10-meter-high biogas digester is properly mixed, and microorganisms are properly decomposed through an anaerobic digestion process, thereby generating methane gas. In order to create an environment in which microorganisms can live, an appropriate temperature must be maintained, and for this purpose, a boiler must be operated. In this process, SLC is operating a digester boiler by recycling the biogas produced by itself, rather than using fossil fuels. Hydrogen sulfide and biogas dissolved in water produces sulfuric acid, so it must be used after a strict pretreatment process. Therefore, biogas goes through 6 desulfurization facilities for purification of hydrogen sulfide as the first desulfurization process. The biogas storage facility is a place to store the gas from which hydrogen sulfide and moisture have been removed after passing through 6 desulfurization towers for the digested gas generated in the Leachate Treatment plant. A 65% methane concentration, which is good methane gas for power generation, is stored, and the amount of biogas generated is about 40,000 to 65,000 cubic meters per day. Methane gas stored in this biogas storage facility is used for fuel for 2.4 megawatt and 1.9 megawatt power generation facilities, greenhouse heating, and boiler fuel for the heating system in SLC. The methane gas purified once is purified once more and lowered to less than 1 parts per million. In addition, SLC has increased the efficiency of desulfurization by using a hybrid desulfurization agent since 2019. Therefore, the estimated generation of 39.2 tons of waste desulfurization agent at the time of design was reduced by 50%, resulting in 19.6 tons. These secondary desulfurization facilities are operated with a 900 normal cubic meter per hour capacity. The moisture contained in the biogas is removed through an 11 kilowatt dehumidifier to prevent the hydrogen sulfide from being dissolved in the water. Since biogas contains a lot of moisture and dust, it undergoes a process of removing moisture and dust to properly treat it. This biogas pretreatment process prevents the formation of sulfuric acid by combining moisture and hydrogen sulfide, and this is to prevent the gas engine of the generator from failing. The biogas that has gone through the pretreatment process is blown to the gas filter through the biogas blower. In this manner, methane gas, from which hydrogen sulfide has been removed by 2 stages of pretreatment, and dust and moisture are removed through the dehumidifier and dust remover, is sent to 8 generators through a pressure blower and a gas filter that removes dust at the final stage. Before being put into the generator, the gas flow is checked and pipes are gathered into the headers. Fuel is supplied to the 8 generators through 8 pipes. The gas engine generator, the core facility of 2.4 megawatts, is a small and medium-sized generator that uses strictly purified high-quality digestive gas as a power source. It transfers mechanical energy to the cylinder and crankshaft by utilizing the explosiveness of 55 to 65% of the methane gas and converts this energy into the electric energy we use by the electromagnetic induction inside the generator. By operating 8 300 kilowatt generators, a total of 2.4 megawatt generators, it produces 9 million to 10 million kilowatts of electricity annually. This is the amount of electricity that 2,500 households can use for 1 year. In this way, SLC efficiently collects and treats biogas generated from leachate and food wastewater through a 2.4 megawatt power generating facility, minimizing odors and generating electricity to generate profits. SLC is participating in the national alternative energy business and contributing to environmental improvement by reducing greenhouse gases and improving air quality. It is a nitrate oxide reduction device. This is a device that utilizes SCR technology that has secured patent rights by conducting joint research between SLC and a domestic company. SLC is producing electricity by reducing nitrogen oxides through SCR technology to comply with the Total Air Pollution Load Management System and minimize air pollution. Additionally, in order to operate the 2.4 megawatt biogas power plant normally, SLC is monitoring and controlling it through the Hmi system. This allows SLC to check data such as coolant temperature, generator status, hydrogen sulfide concentration, and flow rate in real time. The Hmi system is designed to be able to check remotely even if it is connected to a smartphone and away from the facility. The electricity produced through the generator is connected to the KEPCO substation through the transmission line buried underground. It goes through the process of boosting the 380 volts of the generator to the 22.9 kilovolts to supply KEPCO. It is constantly monitored to check the safety of 2.4 megawatt facilities through the power distribution facilities that can control safety devices such as generator controllers, transformers, instrument panels, and circuit breakers. Sewage waste used to be thrown into the sea, but this became prohibited in 2008 with the signing of the Convention on the Prevention of Marine Pollution by Dumping of Waste and Other Matter. This is known as the London Convention. Korea found a way to deal with sewage by converting this to energy and other useful resources like cover soil for the landfill. SLC installed a 4-story sludge recycling facility with a total floor area of 11,800 square meters. This is an eco-friendly facility for recycling resources. The facility safely treats and dries 1,000 tons of sewage sludge per day and converts it into fuel. Sludge collected by the sludge transport vehicle is stored in the sludge storage tank after entering the loading area. Since sewage contains a lot of moisture, it is crushed to make the particles smaller and dried with high-temperature hot air. The sludge is then crushed by a disintegrator and dried in a kiln with rotating dryer at a temperature of 800 degrees Celsius. Drying reduces the moisture content from the sludge from 80% to 10% or less. Crushed sludge is dried more effectively since its total surface area in contact with hot air is maximized. The sealed rotary kiln structure blocks the spread of odor. Additionally, the odor generated by the drying of the sludge in the sludge-to-energy facility is safely discharged through a hot fan and air preheater, through a washing tower, a biofilter, a wet scrubber, and a white smoke reduction heat exchanger. Agglomeration and fixation are prevented through particle atomization, and as a result, safety devices are installed to prevent fire and dust explosion that can be caused in the process. Dried sludge passes through the filter dust collector and the dried sludge cooler, then stored in the dried sludge storage tank. The sludge is molded and discharged later. Wastewater and condensate are treated in a wastewater collection tank. All these processes are automatically operated through a computer control system. Important facilities are constantly observed and controlled from the central control room through a monitor to maximize the operating conditions. In order to prevent fire and explosion occurring from abnormal operation, A fire-water nozzle is installed at the outer part of the inner compartment. The water nozzle is designed to operate at a set temperature of the outlet. In the sludge storage tank, a thermometer and a carbon monoxide sensor is installed to automatically inject and spray nitrogen gas in an emergency. Food waste effluent refers to the wastewater that is extracted from the food waste. Food waste used to be dumped into the sea, but this practice is now banned by the Korean government. The food waste effluent to biogas facility at SLC is an eco-friendly facility that treats 500 tons of food waste effluent per day and 182,500 tons per year. The facility has a total floor area of 3,573 square meters and a building area of 4,724 square meters. After food waste is collected from homes and businesses, it is taken to district facilities where the food waste effluent is extracted and then transported to SLC for processing to energy. The transport vehicle with the effluent enters the loading dock and inserts food waste effluent into a receiving inlet. Impurities greater than 8 millimeters are removed and food waste effluent is transported through screen drums and placed in storage tanks that have 4 agitators and defoamers to efficiently mix the effluent and suppress foaming. It is then transferred to an acidogenic digester, where food waste effluent as an organic matter is processed through both an anaerobic methane digester and a stabilization tank. The facility collects biogas that has been generated during this process and stores it in the upper part of the stabilization tank. Biogas stored in the upper part of the stabilization tank undergoes a refining process in biodesulfurizer and ventilation devices, as well as biogas dehumidifiers, and supplied to the regenerated burner as a high-quality safe biogas. About 23,000 cubic meters of biogas is produced per day that has a methane content of 60% or more, hydrogen sulfate concentration of 500 parts per million or less, and moisture of 5% or less. Food waste effluent in the stabilization tank is then sent to a high-efficiency aerobic reactor for reducing nitrogen content to meet the standards for linked treatments of the plant. The sludge generated during the process is discharged and buried with a centrifugal dehydrator, and the decomposing filtrates are transferred to the Sudokwon landfill site. Odors generated during this process are classified into high concentration and low concentration odors and collected through odor pipes. High concentration odors are burned using a regenerative combustion facility, while low concentration odors are treated in wet chemical cleaning processes and discharged. All processes are automatically operated with a computer control system. Facilities are constantly observed and controlled from the central control room. 200 tons of daily waste, categorized as non-recyclable waste, is brought into the Sudokwon landfill and stored in the loading area. The waste is broken down into smaller sizes using a crusher. Crushed household waste is transferred to the mechanical pretreatment area of the facility. There, waste is sorted in sizes of 100 millimeters and 300 millimeters through a trommel screen. Waste is classified into light and heavy waste according to its weight with a wind separation machine. Waste is sorted into combustibles and non-combustibles by an optical sorter. Iron, among non-combustibles, is sorted by a magnetic sorting machine, while non-ferrous metals are sorted by a non-ferrous metal sorter. Sorted materials are then recycled as valuable resources. The selected combustibles are crushed into pieces smaller than 50 millimeters with a crusher and moved to the drying facility. Here, crushed combustibles go through the drying process in a rotary drum dryer to achieve a moisture content of 10% or less. Waste that passed through the drying facility is reproduced as solid fuel products. A ring die sorting machine shapes solid fuel that are less than 20 millimeters diameter by 50 millimeters length and size. These are then transferred to the cooler storage chamber and taken out through carrying out machine. Fine dust and odors from the drying facility are removed by utilizing deodorizing passage, cyclone dust collector separator, and bag filter. Heat from the deodorizing passage is recovered as thermal energy through a heat exchanger. Odors generated from the loading area and pretreatment facilities are prevented from spreading to areas outside the facility by passing the air through a liquid cleaning chemical scrubber. 1 ton of solid fuel produced at this facility has calories equivalent to around 500 liters of oil. This solid fuel is utilized as thermal energy or electric energy through a dedicated boiler. we can secure new and renewable energy by processing and utilizing waste as an alternative fuel source while reducing the burden on landfill sites.
Methane, produced from landfill gas generated as waste decomposes, is the fuel for producing electricity at SLC's 50 megawatt power plant. Capturing methane is not only important for producing energy, but also for reducing Korea's contribution to greenhouse gas emissions. Methane is a powerful greenhouse gas with 25 times the global warming potential than carbon dioxide, so capturing these emissions is important. Landfill gas is captured via a series of horizontal and vertical pipes installed in the first, second, and third landfills. The first and second landfills produce around 220,000 cubic meters of gas per minute, which is the equivalent of about 20 trucks filled with landfill gas. There are about 1,024 vertical collection pipes for methane gas, and vacuum pressure technology is used to prevent leakage of gas. High-pressure blowers are used to move the gas through 308 kilometers of pipes to the 50 megawatt plant. Roughly 50% of landfill gas is composed of methane, and the other main gas is carbon dioxide and some hydrogen sulfide. Hydrogen sulfide is the gas responsible for the very bad odor in and around landfills, and so SLC neutralizes the gas before it is released to the atmosphere to reduce the negative impacts on the surrounding residents. There are 6 landfill gas incineration units, each combusting 680 cubic meters per minute of gas. Each incineration unit has 2 boilers. In each incineration unit, landfill gas collected is supplied to 2 boilers for incineration through blowers under a consistent level of pressure. Air required for combustion is captured with forced draft equipment installed in the boiler, increased in pressure, and supplied to the boilers after preheated by passing through steam coil air heater and continuous gas air heater to increase boiler efficiency and prevent corrosion. The combustion of landfill gas generates a very high temperature of 1,200 degrees Celsius, which is used to heat water that produces 200 tons of steam per hour. Pure water is used for generating steam, and this is pressurized and superheated above 100 degrees Celsius by a high-pressure feed-water heater. The steam drives a turbine rotating at 3,600 RPM per minute to generate electricity through a 50 megawatt generator, which is completely enclosed and air-cooled. Steam is routed to a Gland system condenser where it is cooled, transformed back to water, and stored in a 500-ton capacity pure water storage tank to be used again for generating steam. The generated electricity is boosted to 154,000 volts through the main transformer and sent to the Gyeong substation along the transmission lines installed in 29 transmission towers. 1.2 million kilowatt hours of power is generated per day by the 50 megawatt plant at SLC. Heat emitted from the condenser and various other devices is absorbed through cooling water circulation. Water is circulated through the condensers and other devices, whereupon it absorbs heat and helps to keep the equipment cool. A cross-flow evaporative cooling tower is used to transfer heat from the cooling water to the atmosphere, and in the process, around 3,000 tons per day of cooling water is discharged into the air. In order to minimize environmental pollution, exhaust gas, which contains nitrogen oxide, another greenhouse gas, is discharged to the atmosphere at a level below 40 parts per million by reducing the amount of nitrogen oxide generated from the combustion process, as well as recirculating the atmospheric gas and reburning it in the boilers. In fact, nitrogen oxide and all harmful substances in exhaust gas are measured in real time with an automatic measuring instrument, and the data are transferred to the Environmental Cooperation of Incheon. The water discharged from the boilers is recycled at the wastewater reclamation plant. Wastewater is treated and discharged following the government standards.
앞서 영상에서 보신 시설들의 연간 수익금은 다음과 같습니다. 2019년 전력 생산을 통한 2.4MW 발전시설의 판매 수익금은 약 8억, 50MW 발전시설은 221억을 기록하였으며 슬러지 자원화 2단계 시설은 18억의 판매 수익을 기록하였습니다. 이처럼 수도권매립지관리공사는 매립장에서 발생하는 매립가스와 함께 바이오가스를 활용하여 전력을 생산함으로써 환경오염을 방지하고 전기에너지를 생산하고 있습니다. SRF 시설 같은 경우에는 SRF 판매 수익, 활성탄 판매 수익, EPR 지원금 등으로 2019년에 약 5억의 수익을 기록하였으며 은폐수 바이오가스 시설에서 생산된 바이오가스는 시설 자체 사용 및 슬러지 자원화 2단계 시설 운영에 활용되고 있습니다. (2.4MW) 바이오가스 발전시설과 1.9MW 발전시설은 은폐수를 활용하였고 50MW 매립가스 발전시설은 매립가스를 활용하였습니다. 수도권 매립지 관리공사는 2019년에 연간 2.7억 kWh의 전력을 생산하였습니다. 이는 4인 가구 기준으로는 약 7만 가구 이상이 1년 동안 사용할 수 있는 전력량입니다. CDM은 전 세계의 지구온난화 현상을 완화하고 지속가능한 발전을 도모하기 위해서 선진국과 개발도상국이 공동으로 추진하는 온실가스 감축사업 제도라고 할 수 있습니다. 공사가 가진 폐기물 자원화 기술을 활용함으로써 기후변화 협약에 적극적으로 대응하고 우리나라의 온실가스 의무 감축에 대비하기 위해서 CDM 사업을 시작하게 되었습니다. 온실가스 감축 사업을 통해 UNFCCC로부터 CER이라는 감축 실적을 부여받게 되는데 공사는 2007년에 50MW 매립가스 발전 사업을 CDM 사업으로 등록해서 2010년부터 2018년까지 CER을 발급받았으며 그 양은 약 880만 톤입니다. 그 중에서 거래, 기부, 자체 상세 등을 통해 520만 톤을 사용했으며 현재 보유하고 있는 350만 톤은 KOC 기준으로 약 1167억 원입니다. 이처럼 50MW 매립가스 발전 사업을 CDM 사업으로 등록하고 온실가스를 저감함으로써 UN 기후변화 협약에 적극적으로 동참하고 폐기물 처리 분야의 선두주자로서 저탄소 사회를 구축해 나가는 데 기여할 수 있었습니다. 물론 폐기물 자원화 시설들을 운영하는 데에는 위험 요소들도 있습니다. 2.4MW 발전 시설 같은 경우에는 발전기의 원료가 되는 소화가스가 지나치게 많이 투입된다면 가동시간이 길어짐에 따라서 질소화합물 또한 많이 발생하게 되는데요. 대기배출 허용 기준을 초과할 수 있다는 위험 요소가 있습니다. 따라서 8대의 발전기를 모두 가동하기보다는 적정 대수만 가동함으로써 대기배출 허용 기준에 준수하여 발전을 하고 있습니다. 50MW 발전시설 같은 경우에는 매립장으로부터 오는 매립가스를 원료로 사용하고 있는데 매립량, 환경 등의 변동으로 인해서 매립가스의 유량과 성상의 변화가 잦아서 예측 운영에 어려움이 있습니다. 부정적 인식으로 인해서 어려움을 겪는 시설도 있습니다. SRF 시설에서 생산되는 고용연료는 악취 발생을 일으킬 뿐만 아니라 화력발전의 보조연료로 활용되고 있기 때문에 미세먼지의 주범으로 인식되어서 지자체의 민원이 존재하고 있습니다. 이러한 문제를 완화하기 위해서 주기적으로 배출구 측정을 시행하고 있고 제조시설과 사용시설 모두 법적인 근거 준수를 하여서 운영하고 있다는 결과를 제시하고 있습니다. 한편 슬러지 자원화 2단계 시설은 최근 화력발전소 가동률 저하로 인해서 고용연료 공급에 어려움을 겪고 있습니다. 고용연료 공급에 맞춰서 슬러지가 반입되어야 하지만 화력발전소 가동률 저하는 슬러지 반입 중지로 이어지게 되고 이는 곧 3개 시도의 슬러지 적체로 이어지기 때문입니다. 이를 해결하기 위해서는 고용연료 수급처를 다각화하는 노력 중에 있으며 고용연료를 다른 방향으로 활용할 수 있도록 그에 관한 연구를 진행하고 있습니다. 은폐수 바이오가스화 시설은 바이오가스를 생산하는 과정에서 황화수소가 포함되게 되는데요. 이는 시설 배관을 부식시킬 뿐만 아니라 전처리가 제대로 이루어지지 않는다면 소화조의 퇴적물이 축적되어서 시설의 효율을 감소시킬 위험이 있습니다. 따라서 이를 적절하게 제거하기 위해 노력하고 있는데요. 기존에는 미생물과 산화철을 활용하였으나 2020년부터는 소화조에 약품을 투입하여서 황화수소 제거 효율을 증대하였으며 운영비를 절감하였습니다.